Hello everyone, welcome. In this video, let us solve this question. So we have t to the power of t is equal to 19. Now, to solve this, the thing is that we're going to think of a number that once we raise it to that same number, is going to give us 19. So let's say we try it out by testing it out. Let's say we have 1 to the power of 1, right? This equals to 1, and this is not equal to 19, obviously. Let's say we try out 2. 2 to the power of 2 is equal to 4, and 4 is not equal to 19. Also, thinking of it also, let's say we try out 3, power of 3, this equals 27, and this is not equal to 19. So that means that, right, if we pick up a number and the number raised to that same number must give us 19. But looking at this same pattern, if we look at 2 and 3, in between 2 and 3, 2 to the power of 2 give us 4, 3 to the power of 3 give us 27, and 19 is in between 4 and 27. So in between 4 and 27, right, 2 and 3, you will get 19. But then the number will not be exactly a whole number. It will be a decimal number, something like this, like 2.1, 2.2, up something like that. But if you keep on testing it, okay, raising up 2.1 to the power of 2.1, no, it will take time, right? So to then precisely get the particular value that once you raise it to that same number, it will give us 19. Let's solve it. So the first thing we're going to do solution, but then if you can solve it, right, you can comment your workings in the comment section and let's see your answer. To solve this, we have t to the power of t is equal to 19. With this, we are then going to introduce natural logarithm on both sides of the equation. So ln on both sides of the equation. So ln t to the power of t is equal to ln 19. Now take note that ln is equal to logarithm to the base of e, and logarithm is simply logarithm to the base of 10. So that means that the same property of logarithm can be used on natural logarithm ln. Okay, so with this, at this junction, if you have logarithm of a to the power of b, this equals power b then becomes b logarithm of a, right? And I said that we can use the same property of logarithm on natural logarithm ln. So with this, power t here then becomes t, then you have ln t is then equal to ln 19. At this junction, to then solve for t, what we're going to do is that we will introduce what is called Lambert W function. So Lambert W function, or it is also called omega function, and also product log function. Okay, so we then introduce the Lambert W function on both sides of the equation. But what exactly is the Lambert W function? Now, if you have W, right, a times e to the power of a, this is equal to a. If you have an expression such that you have a times e to the power of a, if you apply the Lambert W function, you will get a. Also, if you have, let's say you have y times e to the power of y, and then you apply the Lambert W function, what you will get is y. Same thing also if you have, let's say, an expression so that you have, let's say you have b, right, times e to the power of b, right? If you apply the Lambert W function, you will get that same b back. To then apply the Lambert W function, what we'll do is that we'll make t ln 10 to resemble this. And to do this, right, what we'll do is that we'll introduce what is called e, so e to the power of ln. If you have e to the power of ln of x, e will cancel ln, x stands alone. Same thing also if you have e to the power of ln y, e will cancel ln, you have y standing alone. So that means that in place of t, if we bring in e to the power of ln t, e will cancel ln, right, t will stand alone. So in place of t, if we bring in e to the power of ln t, nothing will change, right? Good. So in place of t, we'll bring in e to the power of ln t. So what we then have is t becomes e to the power of ln t times ln t is then equal to ln 19. Okay, so with this, we are almost there to make this to resemble the Lambert W function. But take note of something. E here, right, is in the second place, while this b is in the first place. So that means that we interchange this so that e here stays in the second place and ln t becomes the first place. So ln t comes here, you have ln t, then times e to the power of ln t is equal to ln 19. So with this, right at this junction, we can then introduce the lambda w function on this. So what we then have is that we have w, then ln t times e to the power of ln t is equal to, same thing here also, w, then ln 19. Now, such that if you apply the lambda w function on this, what we will get is ln t, right, is then equal to w ln 19. Okay, to then solve for t right here, we introduce e to the both side of the equation. So we're going to have e to the power of ln t is equal to e to the power of w, then ln 19. So with this, if we cancel ln, what you have is t. So t is then equal to, what you have is e to the power of w, then ln 19. At this junction, we've gotten the value of t. But then you are wondering, okay, why is it that our value of t is not in decimal form? Now, to get the actual value of t in decimal form, what we'll do is that we'll press this in our calculator. So t is equal to, you press e. Now, you will not see w in your calculator, but if you press product log, so if you press product log, then you press in brackets ln 19, what you will get is t is equal to, you will get the value of 2.8303, okay, as the decimal number in your calculator. And that means that if you press 2.8303 to the power of 2.8303, what you will get is exactly approximately 19. So therefore, we've gotten the actual value of t that will give us 19. I hope you enjoyed the video. Please don't forget to like the video, subscribe to this channel, and share the video to your friend. Subscribe now. Thank you very much. See you in the next video.